Hello and welcome to A-Level Math. This is the first video in the series Trigonometry, and in this video we'll be covering the very basics of trigonometry. We'll not be going into the that much basics that you covered in class 10. So this video assumes that you are familiar with uh, the very definitions of trigonometric functions like sine theta, cos theta. So I want you to already know that sine theta is perpendicular by hypotenuse, cos theta is base by hypotenuse, and so on and so forth. So if you're not familiar with class 10th trigonometry, so go to any other video tutorials, because I don't have any video covering that amount of basic knowledge. So please make sure that you're already having that knowledge, and then come back and see this video. So this video assumes that you have that basic knowledge and you already know the trigonometric functions in the first quadrant. That means if I ask you what the value of sine 30 degree, you know about it. So in this video we'll take this study a bit further and explore the values of trigonometric functions in other quadrants as well. So after watching this video, you'll be able to find out the values of sine 270 degrees, sine 335 degree, or something like that, cos 215 degrees, or anything. So let's get started. So as of now, you are familiar with the trigonometry of the first quadrant. So if I ask you to find out the value of sine 30 degrees, 60 degree, 90 degrees, and so on, or cos 30 degree, cos 60 degree, if I give you an acute angle, you can find out its value and for some particular angles. But what we are concerned with is to find out the values of trigonometric functions in other quadrants now. Okay, so the first thing that we'll be learning is that as of now, you just have heard that sine theta, cos theta all take only positive values, because whatever values they took, half, root 3 by 2, and so on and so forth, it was all positive. It was never negative, and because of the fact that the value of theta was always less than 90 degree, and this is why the values of those functions were always positive. But it is not generally the case. We will see and explore in this video that these values can even be negative. Okay, so in the first part, let's just understand in which quadrants which trigonometric functions are positive and which are negative. All right. Okay, so take this first quadrant and let's make up a right angle triangle over here. Okay, so let's make our right angle triangle like this. All right, so you already know that the right hand side for the x-axis is positive, and the upward direction for the y-axis is considered to be positive, and the downward direction for the y-axis is considered to be negative, and the left hand side of the x-axis is considered to be negative. Okay, so in the first quadrant, I have my base positive because this is the positive direction of the x-axis. So my base is positive, and also perpendicular is in the upward direction, so perpendicular is positive as well, and hypotenuse is always positive by convention. This you have to remember. Hypotenuse is always positive. What can change is the perpendicular and base. They could be positive, they could be negative, depending upon the coordinates, and we will see further. Okay, so for the first quadrant, all of these three things, hypotenuse, perpendicular, and base, all of these three things are positive, and therefore sine theta, cos theta, or any other trigonometric function was always positive. Because say for example, if you consider sine theta, it is perpendicular by hypotenuse, so it is something positive by positive, so the answer is positive. Okay, and similarly, if you take anything else like sec theta, then sec theta is hypotenuse by base, which is positive divided by positive, because everything is positive in this case. So we have every trigonometric function to be positive. All right. Okay, so that is why every trigonometric function is positive in the first quadrant. But consider something in the second quadrant. So say for example, if we consider a right angle triangle in the second quadrant now. All right, so we have our base to be negative because it is in the negative direction of the x-axis, but we still have our perpendicular positive because it is still pointing upwards. Okay, so let's write it down over here. What we have base to be negative, and we have perpendicular and hypotenuse positive. All right, so let's write down all of the main three trigonometric functions: sine theta, cos theta, and tan theta. Okay, let's start with sine first. It is perpendicular by hypotenuse. Okay, so what is perpendicular? It is positive. So it is something positive divided by something positive. So sine theta is positive in the second quadrant. So in the second quadrant, we get that sine theta takes some positive value. What about cos theta now? Cos theta is base by hypotenuse. Base is negative. We have already discussed that base was negative in the second quadrant. So negative by positive, because hypotenuse by convention is always positive. So cos theta is negative in the second quadrant, because negative by positive, this ratio is negative. So cos theta is negative in the second quadrant. And what about tan theta? Tan theta, you can think of tan theta as sine by cos, or you can think of it as perpendicular by base, anything you feel comfortable with. So perpendicular is positive and base is negative. So what we get is a negative value. Okay, so tan theta is again negative in the second quadrant. And if you find out the reciprocal, so cosec will be positive because it is the reciprocal of sine, sec will be negative because it is the reciprocal of cos, and cot will also be negative because it is the reciprocal of tan. So I assume that much of understanding from your side. Alright, let's move on to the third quadrant now. So we have discussed so far that all the trigonometric functions are positive in the first quadrant, and only sine is positive in the second quadrant, and everything else is negative in the second quadrant. Okay, I'll be just discussing about sine, cos, and tan. The rest three you have to understand it yourself. Alright, let's take up a right angle triangle in the third quadrant now. Okay, so now the base is negative and perpendicular is negative as well, because it is pointing in the downward direction, and base as before is again in the negative direction, but hypotenuse by convention is always positive. Remember this thing. Okay, so now in the third quadrant, what we have base and perpendicular to be both negative and hypotenuse to be positive. Can you please just pause this video for a second and tell me what will be the signs of sine, cos, and tan? Okay, don't get confused with sine and sine. So what is the sign, SIGN, of sine, cos, and tan? Okay, so sine, cos, and tan. Just pause the video for a second and try to find it out yourself. Okay, so sine theta is perpendicular by hypotenuse, which is perpendicular is negative by hypotenuse is positive. So we get a negative value for sine theta. So sine gives us a negative value. Alright, what is cos of theta? So cos is base by hypotenuse. Base is negative, hypotenuse is positive. So it gives us a negative value. So cos is also negative in the third quadrant, I'm sorry. And tan theta is perpendicular by base, which is negative by negative, which is positive. Negative divided by positive, negative divided by negative is positive. So tan theta is positive in the third quadrant. Okay, and the rest to sine and cos are negative. Alright, so recap, everything positive over here. In the second quadrant, only sine positive. In the third quadrant, only tan positive. Now we move on to the fourth quadrant. Okay, alright, so in the fourth quadrant, we see that base is positive, perpendicular is negative, and hypotenuse is always positive. So what is sine theta? Perpendicular by hypotenuse, perpendicular negative by hypotenuse always positive, so sine theta negative. Cos theta is base by hypotenuse, base is positive, hypotenuse positive, so cos turns out to be positive in that case, and tan theta is perpendicular by base, perpendicular negative, base positive, so negative. Alright, so in the fourth quadrant only cos theta is positive, and the rest all of the and the rest sine and tan are negative. Alright, so remember this thing, all sine tan cos, in this order you have to remember, all sine tan cos. Alright, so you have to always make sure that you always remember this sign, that sine theta can never be uh, negative in the second quadrant. Say for example, if I give you, what this means is that if I give you some angle in the second quadrant, like anything greater than 90 but less than 180 degrees, that is the meaning of second quadrant. So like sine 135 degree or sine 150 degrees, for all these values sine theta will take some positive value. For now I am not telling you what will be the value of it, but for now we have just understood that whatever be the value of sine theta in the second quadrant, it has to be positive. Similarly, if I take the value of sine in the third quadrant, it has to be negative. Only tan theta is positive in that case. And if I take some value in the fourth quadrant, say for example 290 degree, anything greater than 270 degree and less than 360 degrees in the fourth quadrant, so in the fourth quadrant cos is only positive and rest 2 sine and tan are negative. Remember, I am just talking about these three trigonometric functions. I assume that the rest of the three, like cosec, cot and sec, these will have a similar result. So sine and cosec will be positive in the second quadrant. Okay, let me write it down. Sine and cosec positive in the second quadrant, tan and cot positive in the third quadrant, because they are just reciprocals, right? And sec and cos positive in the fourth quadrant. So that's it. So that means suppose if I take any value in the third quadrant, so say for example, if I take value theta is equal to 200 and say in the second quadrant we have 225 degrees. Okay, sorry, in the third quadrant, so theta is 225 degree, belongs to the third quadrant, so tan of 225 degrees will be positive, and similarly cot of 225 will be positive, because we have known that in the third quadrant tan and cot take some positive values. But if I try to find out the value of sine 225, it will turn out to be something negative. It will turn out to be something negative. What is the value? We are not concerned right now. We will learn it, of course, in this video itself. Stay tuned. And cos 225 as well will be negative. So this much you have to understand, in which quadrants which functions are positive and which are negative. Okay, all right. The one more thing that we have to discuss is about the negative angles. As of now I have told you about just positive angles. So what is positive angle? Whenever you move in this direction, you trace some positive angle. Okay, but what if you move in this direction, you will be tracing a negative angle, like minus of theta. Okay, so in this direction, it traces a positive angle, and in this direction it traces a negative angle. So tell me, what is sine of minus theta? So minus theta is in the fourth quadrant, right? We assume that theta is something acute. It might not, it need not as well. These results will hold anyway. So assume minus theta goes in the fourth quadrant, right? So in the fourth quadrant, what do we know? That in the fourth quadrant sine is negative. So what do? You take this minus outside. So sine of minus theta is minus sine theta. Okay, so that means if I ask you to find out the value of sine of minus 45 degree, then you can take this minus outside and you can write it as minus of sine 45 degree. This you can always do. Okay, so these are the things that you have to remember. Similarly, cos of minus theta will be cos theta, because minus theta is in the fourth quadrant. Their cos is positive. Alright, so that is why it has to give you a positive value. It cannot give you a negative value. So that is why this minus sign vanishes, and we are only left with cos theta. So remember, cos of minus theta is cos theta, not minus cos theta. And tan of minus theta is minus tan theta, because in the fourth quadrant tan is negative, so it has to give you some negative output. So that is why minus goes outside. So these are the things you have to remember. Alright, okay. Now, some more thing that you have to keep in mind. You remember in your class 10th that you used to write sine 90 minus theta is cos theta. Similarly, tan 90 minus theta is cot theta. And lastly, sec 90 minus theta is cosec theta, right? These are the things you already know. So these results will still be valid and with some additional features as well. The feature is that you have to remember, whenever this thing is an odd multiple of 90 degree, it will change sine into cos. It will change sine into cos. So suppose if I write sine 90 into 3 plus theta, then this 90 into 3 is an odd multiple of 90 degree, right? So answer will be something cos of something. What will be that something? I'm not coming into that for now, but you have to remember a rule of thumb. The rule says that if there is some angle which is written as 90 into some odd number and plus theta, then sine changes to cos. But if it is an even multiple, say for example sine 90 into 4 plus theta or minus theta, whatever, then sine will not change into sine will not change into cos. I'm sorry, sine will remain in sine. Okay, remember the rule of thumb. We'll take up some examples to understand it even better. For the time being, remember the rule of thumb that sine, and if inside that bracket you find something odd, 90 into some odd number, then change sine into cos. And if you find something even, then don't change. Keep sine as sine, and then whatever comes in the bracket, I'll come to it. And similarly, these logics will hold for tan and sec. So if you find tan and then some odd multiple of 90 degrees, 90 into some odd number or plus and minus theta, then change it into cot. And if you find tan 90 into some even number plus minus theta, then keep it as tan only. Okay, and whatever is in the bracket, will come to it along with the signs. We have to understand a lot of things here, but for now keep this rule in mind. Okay, all right. So let's take up some examples for the very first thing that we have discussed. So you are given the value of sine x. Okay, so sine x is given to be minus 2 root 6 by 5 and x lies in the third quadrant. Alright, so find the values of cos x and cot x. So we already know that sine x is minus 2 root 6 by 5. Alright, so this is perpendicular by hypotenuse. Okay, so we quickly find out the base. What is the base? Base will be under root h square minus p square, which is under root 5 square minus 2 root 6 whole square. Anyway, you can omit that negative sign because it will give you positive answer anyway. 25 minus 2 2s are 4, 4 6 are 24. So that gives you root over 1, which is 1. So we get that base is equal to 1. Alright. So now they have asked us to find out the value of cos x. We know that cos is base by hypotenuse. Okay. So the only thing that you have to keep in mind is this quadrant. In which quadrant is it lying? They are saying that it lies in the third quadrant. Alright, very good. We know that in third quadrant, cos has to take some negative value. Okay, so base is 1 and hypotenuse is 1. So you just supply it with a negative sign, because whatever it is, it has to take a negative value. So this is how you determine whether the answer will be positive or negative, because it is in the third quadrant. It is given that x lies in the third quadrant, and we know that in the third quadrant only tan is positive, cos and sine are both negative. So you just put down the value of base and hypotenuse considering their positive values, and put down a negative sign because cos is negative in the third quadrant. Alright. So what is they are asking for? Cot x, right? So cot is base by perpendicular. What is base? 1. Perpendicular is 2 root 6. I haven't written minus over here because that will be adjusted by the quadrant. Okay, so we assume that It is always both P, B and H are always you take the positive values, and cot is positive in the third quadrant, so you keep it as positive. You don't supply it with a negative value. Alright, so this is how you do it. Given any sign or anything, you just find out the remaining one. So you are given P and H over here, you find out the B, take P, B and H all as positives, and when you find out the value of some other function, just consider what is their value, positive or negative. So you put down the value of B and H without completely ignore the sign for that time when you put down the value of B and H, and then you put this negative or positive considering whether that function was takes negative value or positive value in that quadrant. All right. Okay. So let's take up one more example. Sec x is equal to -2 and pi less than x less than 3 pi by 2. Can you tell me which quadrant this is? So pi means 90 degree, 3 pi by 2 means 270 degree. You can do it yourself. 3 pi by 2 will be 270 degrees. So this is also in the third quadrant. So you see that sec is given to be -2. It has to be because sec, cos are negative in the third quadrant. It's only tan and cot that are positive. So it is expected to be negative, and similarly this was also expected. Alright, so now they have asked you to find out all the other 5 trigonometric functions. Okay, so what is given? We are given that sec x is equal to -2 and our x lies in the third quadrant. Now we have to find out all the remaining ones. Okay, so what is sec? Sec is hypotenuse by base, because cos is base by hypotenuse. So that is -2 by 1. So what is perpendicular? Perpendicular is root over h square minus b square, which is root over 2 square 4 minus 1, which is root 3. Alright, so now you find out what is sine of x first. So sine x is perpendicular by hypotenuse. Perpendicular you put as root 3, hypotenuse you put as 2. I told you, remember, ignore the sign for the time being. Don't think of this hypotenuse as -2, just take its absolute value. So this is root 3 by 2. And now think, what is sine in the third quadrant? So sine in the third quadrant is negative, so supply it with a negative value, and that's it. Similarly, if we are to find out cot x, cot is base by perpendicular. So base is 1, perpendicular is root 3, and what is cot in the third quadrant is positive, right? So either you write down positive or you don't write down anything, just keep it as 1 by root 3. Okay, so this is how you find out all the other trigonometric functions. I keep it to you as an exercise. Okay. Alright, and now to the thing that we were discussing about that odd and even thing. Alright, so once again a quick recap. If you find sine and then inside the bracket you find 90 times some odd number, then you change sine into cos. And if you find sine into some even number, then keep sine as sine. And similarly this logic will hold for others. So tan, then bracket inside brackets tan into 90 into some odd number, then change tan into cot, and 90 into some even number, keep tan as tan. Okay, let's now see this thing in action. So take the first example, sine 405 degree. What your task is to split this 405 like this, 90 into something and plus or minus something. So that's your choice. You can take positive as well, you can take negative as well. So we can write this 405. So what you do, you multiply, you divide it with 90. So 90 times 4 is 360. So 94s are 360 and the remainder is, did I do something wrong? 405, 94 the 365, then this will be 45. Yeah, so 45. So we can write this 405 as 90 multiplied by 4 and plus 45 degrees. So what we can write it down as 90 times 4 and plus 45 degrees. Okay, So now you see, this is 90 into some even number, so we won't change sine into cos, we will keep sine as sine, because 90 into 4, 4 is an even number. Now inside bracket you just write down this remaining angle, sine of 45 degree, but we are not done yet. The most important thing you have to keep in mind is the sign of this. Sign means sign, positive or negative sign. So how to determine it? Okay, so this 405 lies in which quadrant, can you tell me? So 90 into 4 means 360 degrees, one complete rotation, this gives you 360, and plus 45, something over here, right? I'll tell you again. So 90 into 4. So 90 into 1 means this half, this one fourth of the entire circle. That means one quadrant. So this is 90 into 1, then 90 into 2. Okay, let me draw it again. So this is 90 times 1, 90 times 2, 90 times 3, 90 times 4 gives you 361 complete rotation, and then plus 45 somewhere over here, not the full 90 degrees. So it gives you something in the first quadrant. So we know that in the first quadrant everything is positive, sine, cos, tan, everything is positive. So this will take a positive value. Suppose that it would have fallen in the second or third quadrant, then you have to change the sign accordingly. Okay, say for example, if it falls in the second quadrant, then also it will be positive, because sign is positive in the second quadrant. But suppose that if it would have fallen in the third quadrant, then supply it with a negative over here. Instead of this plus, put it as a minus. So now it will be plus sine 45, which is half. This is our answer. So now you see, you can find out the value of sine 405 degree as well. Okay, you have learned something new. Initially, before the beginning of this video, you only knew how to find out sine 60 degree, sine 30 degree, etc. But now you know how to find out any other value, even greater than 360s as well. Anything greater than 90s, you can find out now. Okay, let's take up for one more question. Cot 585 degree. Okay, so cot 585. First, our task is to split this 585. Okay, so I'll erase this. So 90 when divides 585, what do we have? 9 4s are 36, 9 5s are 45, 9 6s are 54. So 9 6s are 540. So the remainder is again 45. Okay, good. So we have got 90 times 6 plus 45. Alright, so 90 into something even number, so don't change cot into tan, keep cot as cot, and cot 45. And now we have to determine whether here we'll be having a plus sign or a minus sign. So first let's quickly draw our quadrants. 90 into 6. Okay, 90 times 1, 90 times 2, 90 times 3, 90 times 4, 90 times 5, 90 times 6, and then plus 45 gives you a value in the third quadrant. In the third quadrant, we know that cot is positive, so we have a positive over here. So positive cot 45. What is the value of cot 45? Cot 45 is 1, right? So plus 1 is the answer, or simply 1. So that's it. Okay. Okay, I told you, remember that you can have plus or minus anything of your choice in here. So let's see how we can do it. Do the same questions another way. Okay, so we'll do all these questions again, but in a slightly different way. Answers will any case be the same. Either you go this way, or the method that I'm going to tell you now. Answers are in any case going to be the same. All right. Okay, so now what we do, we write 405 like this. 90, instead we wrote it as times 4, right? Now we write it as 90 times 5, and then we have to minus something. So 90 times 5 gives us 450. So what should be subtracted from 450 to get 405? So 450 minus 405 again 45. So we can write 405 as 90 times 5 minus 45. Okay. So now 90 into some odd number, 90 into some odd will change sine into cos, and you again put down this thing, whatever it is. be it 45, anything, whatever you get, this plus or minus actually doesn't impact this 45. Don't write it as minus 45 over here. It will not make any impact over here. But now we have to again think in which quadrant it is going. It will go again in the same quadrant, but still let's again understand it. So 90 times 1, 90 times 2, 90 times 3, 90 times 4, 90 times 5, and then minus 45 again back in the first quadrant. Anyhow, the quadrant will never change. Quadrant will always be the same. 405 degree will always lie in the first quadrant. Anyhow. Alright, so again in the first quadrant everything positive, so a positive sign over here. And what is cos of 45 degrees? Cos of 45 degrees is did I write it as my 1 by 2? I think I wrote it as 1 by 2. Okay, so what, it's actually 1 over root 2. I'm so sorry. Cos 45 is, and similarly sin 45 also is 1 over root 2. My mistake, my bad. I'm extremely sorry for that. So you please rectify that. Cos 45 is, and similarly sin 45 is 1 by root 2, not 1 by 2. I think I wrote it as 1 by 2. I'm so sorry. Alright, now again the same question. Cot 585 degrees. So we can write down this 585 as cot 90 times, initially we wrote it as 6 times, right? So 90 times 7 will give us 630, and what to subtract? 5, 9, 13 minus 9 again 4, so again minus 45. So you can write 585 as 90 times 7 minus 45. Okay, now again the decision of the quadrant, in which quadrant is it is lying. So okay, so this is 90 times 7, right? So 7 is something odd, so you change cot into tan, and tan 45 degree. You ignore this entire part completely, and then we have to decide the sign. So 90 times 1, 90 times 2, 3, 4, 5, 6, 7, and then something negative, so in the opposite direction. So again in the third quadrant, I told you quadrants will never change. So in the third quadrant tan is positive, so that is why cot is also positive, so a positive sign over here. So it is plus 45, which is plus 1. Alright, so we're getting the same answer again. Okay, one more question from this example itself. So let me show you how to deal with negatives as well. So let's take up this cosec minus 750 degrees. Alright, cosec minus 750 degrees. So how to deal with this negatives? As I already told you, sine of minus theta is minus sine theta, cos of minus theta is cos theta, and tan of minus theta is minus tan theta. So what is cosec? Cosec will follow the same logic as sine. I told you, whatever these logics are, you just apply those same logics for the reciprocals. So cosec minus theta will be minus cosec theta. Okay, so we can write cosec minus 750 as minus cosec 750 degrees. Alright, now again we have to do that same thing. So what we'll be doing, we will be writing this 750 as 90 into something plus minus something. So quickly divide 750 by 90. So 9 ones are 9, 9 sevens are 63, 9 eights are 72. So 0 and then 30. So we write it as 90 times 8 and plus 30 degrees. So 90 times 8, this is even, so cosec will not be changed, cosec will remain cosec, and 30, and this is cosec. So quadrant, in which quadrant it is? It is in the 90 times 1, 90 times 2, 90 times 3, 90 times 4, 90 times 5, 90 times 6, 7, 8, and plus 30 in the first quadrant. So everything is positive, so cosec is also positive. So always remember, you have to consider this thing, not this thing. Okay, so whenever you determine the sign, consider this function, not the changed one. If you are to change it in some cases, don't take this. All right, so this is positive, so we multiplied with a positive. entire thing. So the final answer will be minus cosec 30 degree. Okay, so plus minus gives you a minus sign. So minus cosec 30 degrees, which is minus, what is cosec 30 degrees? Cosec 30 degrees is reciprocal of sine 30 degrees. So minus half reciprocal is 2, right? So minus 2 is our answer. Okay, now one more question. These actually examples are all of similar kinds, but initially we were given angles in degrees. Now we are given angles in pies. So let's see how to deal with this. So make sure that you know that pi is 180 degrees, so definitely pi by 2 has to be 90 degrees. So what we were discussing in the previous slides was that 90 into some odd number or even number. Now you have to think of pi by 2 multiplied by some even or odd. Just replace 90 with this pi by 2 and that's it. Okay, so let's take up the first question. Sine 31 pi by 3. Now we have to write this down as something like, initially we wrote it as 90 times something. So now we have to write it as pi by 2 times something and then plus minus something. Okay. So how to do it? So this one is even easier than the previous one. So what you do, 31 pi divided by 3, right? So what you do, you write this 31 as 31 pi as 30 pi plus pi, and then we have whole divided by 3 over here. Alright, so the whole point is that I want these first two things to get cancelled out. So we can write it as 30 pi by 3 plus pi by 3. So always try to break it in such a way that the first number is divisible by this denominator. So suppose we'll take this one example. So we'll write this 41 as 40 times something, because 40 is divisible by 4. So I'll come to it, but just for your understanding, so why we are taking as 30 and not something else, that's it. So 30 divided by 3 is 10 pi plus pi by 3. Alright, now we can write pi as pi by 2 into 2. This we always have to do. Even if you are getting answers in terms of pi, write pi by 2 into 2, and that is how you adjust it. So now you multiply this 2 with this 10 and adjust. Okay, so what we have is sine 20 pi by 2. So you see that you get again 10 pi, which was actually the thing, just a manipulation, because we want to have pi by 2 over here. That's it. So 20 times pi by 2. Okay, let me write it down over here only. Pi by 2 times 20, and then what remains? Plus pi by 3. Okay, so you write down plus pi by 3. So we delete this negative sign. Okay, now this 20 is something even, so sine will not change into sine. Sine will not change into cos. The sine will remain in sine. And you forget about entire this part, just sine pi by 3. And now what you have to do, the most important part, determining the sign, positive or negative. So pi by 2 20 times. So pi by 2 means 90 degree. 1, 2, 3, 4, 8, then again 12, then 16, and then 20. Alright, and then plus pi by 3 will give you something in the first quadrant, right? Because 4 gives you one complete rotation, so 20 will actually give you one full circle, and plus pi by 3 will again be the first quadrant. Okay, alright, so first quadrant everything is positive, so this has to be plus sine pi by 3, which is sine 60 degrees, which is half, sorry, root 3 by 2. I've forgotten the 10th level mathematics, I think. Oh, okay, I'm sorry, my bad. Okay, let's take up one more question. Cosec minus 41 pi by 4. Okay, cosec minus 41 pi by 4. So what you do, You take this minus outside because cosec minus theta is minus cosec theta, so it is minus cosec 41 pi by 4. Okay, now what we do, we write 41 pi as 41 pi by 4 as 40 pi plus pi, which is 41 pi by 4, and then we split it again. 40 pi by 4 plus pi by 4. That gives you 10 pi plus pi by 4, and again can be written as 20 pi by 2 plus pi by 4. So we can write it as 20 pi by 2 plus pi by 4. Okay, so let me erase all these stuffs so that I can have some space to write. Okay, so this 20 is again even, so cosec will remain cosec. So minus we keep as it is for now. Cosec will remain cosec. Pi by 4, and now again determining the sign. So 20 times means one complete circle, and then plus pi by 4, again pushing it to the first quadrant. So everything positive, so we multiply with a positive this entire thing. So final answer will be plus minus will give you a negative sign, and minus cosec pi by 4, which is minus root 2. This is our answer. Okay, that's it. So I hope that questions are clear to you, and believe me, even if you are getting just a little bit idea, you will now understand all the concepts once you go through the solved examples in your book. Just push your limits a bit further. Don't just restrict yourself with whatever we are doing over here. Apply your amount of efforts as well, and that's it. We have covered the signs of trigonometric functions in different quadrants and manipulations of trigonometric functions to find their values at different angles. That is what we have covered in this video. There are a lot more videos to cover on trigonometry because it actually requires a lot of practice, so I'll make sure that I include all those practice materials, and also you have to study hard at the same time. So thanks a lot. Bye bye. Study hard, study smart, and keep watching A level maths. Thanks a lot.